Today's video will cover the procedure to determine the heat capacity of the calorimeter for the Hess's Law Lab. I'll also be giving you data for part 1, and I'll also be giving you hints to work on the calculations for part 1. So it might be a good idea to have your lab handout ready so that you can follow along with the procedure. You can take notes and you can record any data that I give in the video. So we've done calorimetry before. You just did a specific heat virtual lab with a calorimeter, and we didn't really take into account how much the calorimeter absorbs heat. Although it's not going to absorb a whole lot of heat, it does absorb a little bit of heat. Most of the heat released is going to be absorbed by the solution, but the calorimeter is going to absorb a bit of heat. So we're going to be able to correct for that value of heat absorbed by the calorimeter, and it gives us more accurate results for our heat of reaction. So in this lab, you're going to actually get to do that and see how that's done and see the very little change that it does make in the calculations. So that's why we would determine the heat capacity of a calorimeter. So the procedure for determining the heat capacity of the calorimeter is on page 3 of your lab handout, so you may want to turn to page 3 to follow along. And I'm going to use the diagram on the screen to kind of give you a little info on how that you would actually perform this lab. So you want to have your calorimeter ready. You can see that I have nested styrofoam cups. You can also see that there's a cover on top of the styrofoam cups to keep the heat in so none escapes out into the environment, and a thermometer to check for temperature change. And you can also see that there's a magnetic stirring bar in there because as we are mixing the two different temperature waters, we want to be able to have a magnetic stir bar in there to mix the waters together. So the first thing we're going to add is room temperature water. So I'm going to add 50 mils of room temperature water. And it would be distilled water that we would be using. And the temperature of this water, if you want to record this on your data sheet, I'll give it to you again, but the temperature of this water is 22.9 degrees C at room temperature. The next thing that we're going to do is heat water separately in a beaker, and we're going to want to heat it up to about 70 degrees C and add 50 mils of that water into the styrofoam cup, or the calorimeter. I guess I should be using proper lab terms. Okay, so the next thing that we're going to do is take that heated water that we've heated, again adding 50 mils of that hot water, and this water's temperature was 61.1 degrees C when we added it into the calorimeter. The next thing that we're going to do is record temperatures every 20 seconds for 3 minutes. And when you're done recording the temperatures, then you will dump the water in the sink and you would dry your calorimeter and get it prepared to do the actual reactions, which is part 2 of this lab, which is the next video. Today we're just going to focus on adding the room temperature and the hot water to the calorimeter, mixing and taking those temperatures every 20 seconds for 3 minutes. So on this slide I have given you all the temperatures that were recorded every 20 seconds for 3 minutes, and I've also given you the initial temperatures of the room temperature water and also of the heated water. And what you should do now is pause the video, turn to page 5 in the handout, and record the data and the heat capacity of the calorimeter data table, which would be for part 1. So pause the video now and copy that data into your data table. Okay, so the next thing that I want to do is move on to the calculations, which are on page 7. I also will have them on the screen as well. And so I'm just going to work through some of the calculations with you just to kind of give you a heads up and explain a little bit. I'm not going to give you the answers. Obviously, I want you to use my hints to help you calculate in this calculation section. So the first thing you can see for part 1 calculations on page 7 is that you are going to be plotting the temperature versus time on the graph that's given there. So you're going to have some of those first few data points kind of be maybe a little all over the place. And you'll have 9 data points, and whoops, I didn't want to do that. Let me go back there. Okay, sorry about that. So maybe you're going to have data points that, I'm just putting data points in that you might have for your data. And so you have all these data points, and then what you want to do is draw the best fit line through those data points. So let me just go ahead and do that. So maybe I would have a line that looks something like this. Now, I did not graph the data that I gave you. I just put points on the graph to remind you on how to draw that best fit line. The next thing that you want to do is extend the line back. So you want to take this line and extend it back and see where it crosses the y-axis and record the temperature where the line crosses. This would be your T mix. So where it crosses right there would be your T mix, and you're going to record that on your data table. So that's a number 1 and a number 2. Now the next question wants you to calculate the average temperature between the initial temperature of the hot water and the initial temperature of the cold water. So you're just adding those two temperatures together that you started with, the 61.1 and the 22.9, I believe they were, and dividing by 2. So you're just taking an average, and that is going to be recorded on the data table as T average. So you'll want to be recording that in part 1 data table. So let's take a look at number 4. This is something slightly different than what we've looked at before because it has to do with the heat absorbed by the calorimeter. So in number 4, it's asking you to determine the heat lost by the water, or Q water. And the difference between the T average and the temperature of the mixture is due to the heat lost by the water and absorbed by the calorimeter. So we are going to calculate the Q of the water. And you're going to use the equation that's given. So we're looking at this equation right here that I've just starred. And you're going to plug in the grams of water. Make sure that you're taking the mass of the hot water and the mass of the room temperature water. Just a reminder that if I have 5 grams of water and the density is 1 gram per milliliter, that means if I have 5 milliliters of water and the density is 1 gram per milliliter, that means I have 5 grams of water. So with however many milliliters you have of water, it's going to equate to the grams of water because the density is 1. The specific heat of water, C sub P, is 4.184. I know your lab tells you to use 4.18. Either one is fine. It doesn't matter to me which one you use. And then you're going to calculate the temperature change between T mix minus T average. So that's kind of like your delta T that you would use in a normal Q equation, except this time you're looking at the difference between the average and the mix temperatures, which you just calculated, and you can plug those in, or you have on your data table. Now, one thing that you need to be mindful of is that the Q of the water is equal to the negative Q of the calorimeter, because the water is if I'm looking at the water releasing heat and the calorimeter absorbing the heat, then they're going to be opposite in sign but same magnitude. And because the water's releasing heat, it's exothermic, we should get a negative value when we calculate the Q of the water, because the water's releasing heat to the calorimeter. So if I end up with a value for the water that's negative, and I'm saying that that value is equal to the negative Q calorimeter, that means I'm saying that it's negative of a negative value, which essentially equals a positive. So Q cal should be positive, and that should make sense too, because the calorimeter is what's absorbing the heat, and we can kind of look at it in terms of it being endothermic. So I just want to make sure that you get those signs correct when you're doing your work for number 4. You should end up with a positive number for Q cal. And then number 5, you're calculating the heat capacity of the calorimeter. And just remember that the heat capacity means how much heat the calorimeter is absorbing when 100 milliliters of solution changes by 1 degree C. So you're going to use the equation that's given to you, C sub cal equals Q cal divided by the difference in temperature mix minus the initial temperature of the water. So T mix you get from the graph, so that is that point where it crosses the y-axis, and then T initial is what the room temperature water was when you started your experiment to determine the heat capacity. And then this is going to give you the heat capacity, or the C of the calorimeter. And it should be a pretty small number in joules per gram degree C. In joules per degree C. There's no mass in this. We're just taking the heat over the temperature. So your unit should be joules per degree C for heat capacity, because we're not doing specific heat capacity. That would take into account the mass. We're just doing heat capacity. So those should be your units for your answer for number 5. And then you're going to record that heat capacity in the data table on page 5 of your lab handout. So you've collected a lot of data today. Your calculations you can work on using the hints that I gave you, and record the necessary information into the data table as well. Now, a couple things that I want you to be aware of as far as the assignments. I am going to give you assignments at the end of each of the videos, things that I think you should work on just to stay on top of things. There's no due dates for these items, because the entire lab is due on May 21st, and the things that you're calculating along the way are going to be what you're using in your calculations, data table calculations, and your analysis questions. So when you write the lab up, it'll be nice if you have all of that stuff done, then you can just add it into your lab report. If you wait till the last minute, which you can do, I don't recommend it, but you can do, you're going to have a lot of data graphing and calculations to do right before something is needed to be handed in. So if you do the assignments when they're assigned at the end of the video, you'll stay ahead of the game, and it'll be very easy to write your lab report when it comes time. By Tuesday, Wednesday next week, you should have everything you need to do that. So I just want you to keep that in mind, that the assignments I give you are more of a guide, because like I said, everything's due on May 21st. So I hope this was helpful. Tonight I would try to work on these part 1, the data, the graph, and the calculations. And if you have questions, please reach out and ask. You can do that via email, or you can also do that in the forum that's set up for questions. Have a great night, guys, and we'll see you in the next video.